bullshit, I can't hear you. Sound off like you got a pair.
Yeah, I'm moving slow tonight, Gumby. I'm getting everything set up. What's up, man? Oh wait, the timer didn't start. Crap. There we go. Alright, cool. Let's get this boat on the road. Sorry, I'm moving slow tonight. The kids are sick, and I think I'm fending off whatever. I think Sock and I are both fending off whatever they've got. You can get free computing with your public repos on GitHub. I mean, it depends on how you set it up, but yeah, kind of. All right. Man, I was just sitting here, happy as a clam, doing stuff, and completely forgot to even get HackBot online. Let me do that real quick. Okay, getting online. We'll get the siege run started here in just a second. Like I said, I apologize. I'm moving slow. I tried to catch a nap before the stream, and I think that just made me even slower. All right, let's kick this off. Whoop. That is suboptimal. Hang on. Where's the screen? There it is. All right. I guess it would help if I turned on NDI. That would help. What's up, everybody? All right, let's get everything kicked off here. There's our IP address. Let me get the seed run up and running. It's our test data. Here we go. There we go. And let's kick this puppy off. Actually, hold on. Before I do that, I don't think I actually connected into the VPN, which would make this a really tough exercise. Yep, sure not. There we go. I did download it. I just haven't had time to go set it up yet. So, yeah, I need to go do that. Well, actually, there's two parts to that. One is the external part, and the other part is going to be I have to go set up the security restrictions to where we're supposed to have the Python escalation path. So I've just been spending time other places. I haven't set it up yet. All right, now we should be good. Let's go ahead and... before I do that, hold on. I want to make sure this box is up. Okay, cool. It's up. Let's run it. Let's see how Claude 4.5 actually does with this real quick here. So one of the things we might need to go do is update all the prompts, because I figured this out. I haven't talked about it on stream since I did, but last Sunday we had an issue with this. All of a sudden, half the language model calls weren't returning any explanatory text. They were just returning tool calls. Not a huge issue in and of itself, but I specifically structured all the calls in HackBot to get both pieces of information so we could kind of see what the reasoning of the language model was. Reasoning using that term very loosely. So we might need to go do some updates to those prompts in there. It's not such a big deal. But yeah, I hope everybody's having a great Saturday. Had a pretty chill one just around the house. Probably gonna have one tomorrow. Agent Zero and Honey Badger are both sick and just miserable and want to, you know, they only want to get snuggly whenever they're sick and gross and want to infect you with it. So that was pretty much today. Honey Badger actually had to sleep in our room last night because I have a recliner in my bedroom. So I could prop him up in it because poor little guy, he's just snotty and gross. And so I could prop him up in the recliner so he could at least sleep and not be choking all night. Poor little guy. And then Agent Zero is going through the same path that Honey Badger did right now. Let's see what this guy is doing here. So how did our exploit planner kick off? Let's see. What kind of plan did he come up with? This will be interesting to see because notice how here... Oh, actually, take it back. So it said navigate to the upload form, upload the PHP shell, access from uploads, test execution. We'll have the 2 injected tasks at the end there. So it should be okay. We'll see what it does. Yeah, basically it's passing around the house. And so we'll probably not end up going to church tomorrow because don't want to go pass that around there. But just the way it goes, man. Way it goes living in plague season. But I did do some extra work today while the kids were napping. They took a long nap, and so did Sock because she didn't sleep well last night. Because Honey Badger was in our room and making noise like coughing and sneezing and all that other stuff while he was asleep. So she and the kids went down for a nap. I was working on the workflow for putting out the YouTube videos. I think I've got a pretty decent one worked out. It'll be interesting to test. All right, let's let this run for just a second here. Let's see how far it's gotten. All right, so it got the web shell. It called the browser to upload it, or to navigate, and then to upload it. Okay, and then it calls a rename file. Okay, excellent. Now the question is actually, did the revisor, did it do the insert step correctly? Okay, it did do the insert step. Oh, that's a fail. .jpg. Kill me, Smalls. All right, so it's going to rename the file here. And then now it's going to try uploading it again. And then what's the revisor going to say now? Oh, well, I guess the upload validated, but then it's going to try and... Let's see what else it's going to try and do now. Let's see. So it's going to try to do get on webshell.jpg. What did the revisor say about that? Let's see. It validated it. Now, why is it going to try and do a get again? Let's see. Oh, it's going to try it with command who am I. That's going to fail. Okay. So since that fails, let's see what it tells us down here. And this is the part I was talking about. So the status here, this API call, this language model call is not returning any of the reasoning about why it failed. And so then it's going to say, oh, we'll try ID or password. So it's going to try and actually go get... Actually, what was your task here? Let's see. Oh, it's calling the web shell dice code. Okay, that's good. It's not generating a new artifact. It's trying to use the built-in function to call it. And then that's going to fail. Identify and use a double extension technique by renaming the web shell to JPEG PHP. All right, cool. So it's going to rename it. It's going to try and re-upload it, and that's going to fail again. It probably hit a recursion limit in here. Let's see. Cypher, what's up, man? All right, let's see. So then it renames the web shell to JPEG PHP. That's not going to work. And then, wait, hold on. Then what's it going to do? So it validates that, but then what's the next step what's the next step it's going to try and do? So it does rename it, however, it doesn't ever re-upload it here. So this has led me to a worrying conclusion here, that our structure and our tasking might be too rigid. Oh, here we go. So here it's saying that it failed upload the JPEG, so then it tells it to re-upload it. Goes through, re-uploads it. And then what does the reviser say to that? Oh, so it failed it. It said rename the web shell to bypass the extension filter. Oh, wait, it's because it renamed it to PHPJ. Oh, God, this thing is just, it's going off. It's not going off the rails. It's just taking the hardest path possible. It's brute forcing and trying a couple of different ways in here. So obviously the JPEG, the .jpeg version wasn't executable. The JPEG PHP version was blocked from being uploaded. So now it's like, well, let's try PHP JPEG. Like that's not how this is gonna work. and then it looks like it probably hit a recursion limit up here. Oh no, it hit an out of bounds? Oh, interesting. Oh, you know why? I think because it failed in here. Oh no, it's because the step processor didn't return anything. Oh, this makes me worry here. So now the question is, by looking at this, let's go back and break it down here real fast. Because it did a lot of stuff in here. So the exploitation agent really just went ham on this. So in theory, that run costs about 78 cents. Not bad. But let's see what the exploit agent actually did here. All right, so we called the exploitation agent. It said we're going to upload the web shell through panel and access it via the uploads directory. So then the planner comes through. It gives us a pretty solid plan. Get the web shell up, go to the panel, upload it, test that it's available in uploads, and test for web shell execution. So then if we go to the processor, first thing it does is, so it gets a copy of the web shell artifact. It goes through and it uploads it. Everything's looking good up through here because we just looked at it. Except when it tries to upload it. If we look at the summary right here. Attempted to upload the PHP web shell through the upload form. It was blocked with PHP not permitted. Okay. So now here's the kicker. Let's see what happens with the state table. Because we're going to start making changes to it. So we're going to rename the web shell to a .jpeg extension before uploading. So it comes through, it renames that. Actually, hold on, let's go back. Oh, damn it, I lost the spot where I was. Crap. I hit the wrong button. So let's look for the first renamed file in here. Okay, so here's where it renames it to a JPEG, thinking that's going to work. Come on. Hydrate. Hydrate already. Okay, so it validates that it got renamed just fine. And now, also, one thing to note here is, when it did this, it did it with an insert step. So the reviser actually did come in and say, if we look at the reviser previous to this, right? we get an insert step, which is great. So now we've got a step before uploading, which was rename it to a .jpeg extension, rename the file, then it should come through and try and upload it again through the special agent. Special agent's going to come back and say, successfully uploaded the PHP web shell through with the .jpeg extension, yada yada, everything's looking good. So then it should try to call it here. Yeah. Upload the web shell through the upload form. Oh, wait, hold on. This is the reviser. I take that back. So that validated. So then, what was our next task here? Oh, access it. Basically make sure it landed properly. So it does an HTTP GET to look at that. And there's our output, which is all of our web shell code. And then the reviser comes back and says, okay, that was valid. And now our next one is test the web shell to confirm command execution. So to do this, it does it with the HTTP GET, which is no big deal. Does it with who am I? That's a valid option. But when it comes back, we just get the code again because it's not actually being executed as PHP. So the reviser, now this is the kicker. This is where it actually goes from here. So test the web shell using the command that produces a visible output such as ID or PWD. Well, those all should have been visible outputs. Should have been just fine. Now the kicker here is also it doesn't insert it. See that? So let's see how it error corrects in here. So it's redoing this option here, right? So the command was test the web shell to confirm execution, but now it's overwritten that task and said, hey, we're going to just test it with ID or PWD, which is not a bad idea. And it does that using the built-in function we already gave it with the ID command. The reviser is going to come back and say what? Identify and use a double extension technique by renaming the web shell to use JPEG PHP extension. All right. So then we rename the file again, but then I don't believe at this point we actually have. Let's go over to the updater here. Let's go look at the tasks as they sit real fast in the state table. So let's get into our tasks real quick. Task 5. Okay. So here's all of our steps. We got the web shell, navigated to the panel, renamed the extension, because this was an inserted step here. Uploaded through the web shell form. That was successful. And then it tests it for code execution, which fails because it's the wrong extension. And then it says identify and use this, and then test the web shell. So it wants it to rename the extension and then hit it here, which I believe the reviser actually does come through and say, hey, you got to do this differently. Or not. Let's see. Oh, because it just says the rename. All right. So now the next thing it wants to do is try calling it. However, it's going to try calling it with webshell.jpg, which is not the correct one. So the reviser is going to fail that. Okay, so upload and the renamed web shell through the upload form. Okay, not a bad idea. So then it does call the browser agent. Browser agent comes through. It should say that that is blocked with PHP not permitted. Come on, scroll. There we go. Yeah, because it already realized that, hey, this is why this got blocked. The .php extension isn't allowed, which is kind of wild that the reviser didn't catch that. Because we told it already knew the output. It said .php is not allowed, but it's like, hey, rename it to JPEG PHP. That doesn't freaking work, dude. So the next one here, let's see. Upload that. That should have been insert step true. Wait, hold on. It just did that though, didn't it? Oh wait, yeah, it should have said that it failed because it was JPEG PHP. So then it's like, well, what if we use php.jpg? Going in circles. So PHP JPEG should have completed. Successfully uploaded. Okay. But then let's see what happens here. So now we're at the end of the string here. But then somehow we get like out of bounds with this. Okay, so then it calls it to the upload form here. However, I think at this point it failed out of the task. No, it actually sent back to the exploit step processor. So we told it to upload the renamed PHP JPEG through the upload form, which, did it actually do that? Let's see. Let me copy this info out real quick. Let's take all of this, copy. Let me just drop it over here into Notepad real quick. Okay, let's turn off word wrap. Okay, so here's what we've got for it. So we told it to, and this is at the end of the exploit chain, right? We told it to upload the renamed web shell PHP JPEG. So actually here's the list of everything that it's done so far. So get the artifact, navigate to the upload form, upload with the .jpeg, or rename it to upload with the .jpeg, upload the PHP web shell through the form. It gets blocked. And so there was a revision here earlier where it said, what did it say? It first tried it to upload it with .php, and then it overwrote this task to upload it as a .jpeg right here. So then that fails, and then it wants to access it from uploads. That pretty much fails. Identify a double extension technique, and we get web shell JPEG, rename it to PHP JPEG, and then we want to upload that to the upload form. Yeah, this is a bit too... Damn. This sucks because I like this structure, but unfortunately, I think the structure is too rigid. And I think we've not given it enough autonomy to go through this. Let's think about this. So what happens currently here is we've got basically a nested list in here. So I think that's working okay for the primary agents, except for the exploit task. So what happens is we have a list of tasks that are happening here. God, that is terrible. So we have a list of tasks that the agents are supposed to perform. So we got some for recon, some for enumeration, and then finally we get some for exploitation. So the exploit task is just basically, hey, get our web shell on there so we can do remote code execution, right? But the steps to actually happen with that is actually nested under this task as an exploit task. So the exploit task then has its own set of tasks or steps that it's going to do. So under the exploit task, we then nest in a bunch of steps that are going to happen in here. So we've got our steps happening. And what it's doing with this is then we've got first step, second step, third step. These steps can actually come up and overwrite previous steps as part of the loop. So then we'd have a different step that takes its place. And this is the final rendering that we get. So the idea was solid, but ideas rarely survive contact with any kind of live fire exercise. So it looks like this is a bit too rigid of a structure for these steps in here. Hmm. Let's go look at something real fast. Let's go take a look at how the exploit steps are structured. So let's go over to the states here. So here's what I'm talking about. This is our main state tip where here there's our tasks. And then a task is going to be a list of some kind of a task in here. And if you're wondering why it's done this way, is because it's basically for sending stuff to the language models for processing. It gives them a structured output so they know what shape of data to return. And then here's our actual exploit task, and here's our exploit steps right here. So our steps, we have a task, a status, a tool, and an output right here. So how do we want to restructure this? Because we're going to have to. That's what's happening here. Part of me says, do we just take this and basically make it use the working memory to keep track of this? Or basically use the output here as a kind of working memory? Let's think about this. So the exploit step currently has, we have what the task is, we have the status, our tools, and our output. And this is basically a one-to-one match. So whatever tool we called, that was our output right there. So from our exploit tasks, how could we restructure this? And what sucks is it's going to take a good amount of refactoring to do this. Because a lot of times it's looking for kind of these exact values in here. I don't want to approach this. So what I'm trying to think is, this was actually pretty easy to kind of think about because it's very structured. At the same time, let's think about it how a person would actually handle this. Typically, you're not going to come through and structure this in this exact way. Probably what you're going to do is you're going to have a list and you're going to be manipulating it as you go. Like something like in this text file here, right? You'd have like the steps of tasks that you, the list of steps that you did. And then finally what you do is you'd come back and say, okay, actually I needed to do this step up here, but I got to rearrange this stuff. So the question is, how do we want to implement that kind of thinking over into it? So if we take out the steps here, let's start with the exploit task, right? We have a task. See if I can do something here. So that might make this a little bit easier. Let's blow this up. All right, not bad. Yeah, we might be able to work with this. There we go. Okay, so this is what we've got currently. So I think we want to keep this part right here. So the overall task, we want the status, whatever our verdict is. This, I'm not sure if we're going to keep. This, I think we can change. I think instead of being a list of exploit steps, we literally just make this a memory scratch pad. So what if we change this to something like a scratch pad here? So our scratch pad could basically be more or less a, that's terrible. The scratch pad could basically be nothing but a text field that it could go through and try to run all these things about. So this part we definitely want to keep. This part we need to keep, which is the initial access exploit. I'm wondering if these steps, and then actually, rather than working on the steps in here, yeah, I think this is probably the way forward, because I think the data structure is too rigid. We're not giving the language model enough ability. We're not giving it enough context. We're not giving it enough ability to be freeform with how it's acting. So we've given it not enough agency. Hey, Ponder, thanks for coming online, man. Welcome in. I hope you're having a great Saturday. A stupendous, a super, a saucy Saturday? I don't know. I'm trying to think of S adjectives. Yeah, I think this needs to go. Should not be a list of exploit steps. Actually, I'll take it back. Let's look at the exploit step structure. Maybe this is what needs to change right here. Let's go put this in real quick. So this is our exploit steps right here. Let's highlight that real fast. So that's our exploit step. So right now, whenever we're sending the data, we're sending very precise small chunks. So like we will never send like the entire list of the exploit steps. We have the step planner give us the plan, and then we build the steps on our side based off of that. The language model doesn't know anything about it. And so all of these that we get back from the language model, they get turned into steps here. Maybe this is actually where that needs to happen. Maybe these, so we would need to keep this part and maybe that part. But the question is, I think the tool and the output tracking here, I think those might need to change. Basically, what if we just turned this into a single thing and we make that the scratch pad? So there's a couple of changes that need to happen here. I think these two things get combined into this scratch pad here. So we won't have a definitive list of tools. We won't have a definitive list of output. We'll just have tool, output, scratch pad kind of happening here. So we know what all steps were taken during this. And then I think instead of sending all of this over, let's erase this part here. All of you go away. I need to get the iPad set back up so I can actually diagram with the pen. There we go. Here's what I'm thinking. It's basically we send this whole thing over to the language model, this entire list of exploit steps, for the reviser to look at, and then let it make an update over the entire list of steps in there. That would give it complete context for when it needs to go through and work on it. So we'd still have the status, so it goes through and it finds the first working one to work on. But then whenever the reviser comes back, rather than modifying an actual exploit step, which it's been doing, we have it modify the entire list of steps. Oh, that's going to suck to implement. Because there's so much checking logic that happens with all of those. Oh, that is not supposed to happen. Yeah, we turn those off. Boop. There we go. Yeah, I think this might be... I think this is the way forward here. Crap, that's going to make so many changes in here. So this is going to be done to the revisor. I was hoping this would not be the case, but it just looks like every time we run this, what's happening is the task list just gets completely polluted and corrupted, and it turns into utter dog crap. Lame. All right, let's look at the structure of it real fast here. Let's go to the exploit agent here. So for the exploit agent, when it operates, bring these over here out of the way. So here's the primary loop, right? Hey, Ponder, what's up, man? I've been retooling my skills the last 12 months, playing around with agents like LangChain, OpenAI, Agent Builder, and Microsoft Agent Framework for my home lab. Nice, dude. I have not messed with... So I'll be honest, the only language model and agent framework I've really messed with is LangChain and LangGraph. And I know a lot of people aren't super happy about it. They think it abstracts too much away. It's been working just fine. We've not hit an edge case where there was something we needed to do that we could not do in the two frameworks here. I've been meaning to mess with some of the others, but realistically, it's been handling it just fine. LangChain handles all the language model interactions just fine. Now, I might change my tune here in a little bit because currently we're using LangChain to talk directly to Anthropic. I'm probably going to retool it to talk to OpenRouter. And the reason why is because OpenRouter presents everything as an OpenAI compliant API. The good thing about that is I've also got another backer that's coming on that's going to give me access to Bedrock, to their instance of Bedrock, so that I can run things up there. That's going to be really cool because I'll have a lot more compute power to throw at this and try and figure some of these things out. The downside is that... Actually, there really is no downside. Actually, yeah, there is a downside. The downside is I got to make sure I retool everything in here to look like it's using OpenAI instead of Anthropic. But hopefully that even shouldn't be too big of an issue because over here in the code, we've got the basic language model that gets exposed in here from this guy. So not such a big deal. This originally had a lot more in it, but the idea is we should be able to come in here and rather than importing like chat Anthropic, we'd be able to import chat OpenAI, modify it a bit and bring it in here. Eventually, I wanted this to support lots of other different APIs anyway. So that's just going to be a next step. Maybe we'll work on that next weekend. It depends on when I'm going to get access to that Bedrock instance. All right, let me come back over to the agent flow here. So the step processor goes through and makes all of our exploit steps. That's extracted away as a function call. So we'll need to go modify that function call. The step processor then goes through and looks at each of those steps. It executes on it. It makes modifications to the state table, which affects those steps. So we'll have to make changes to the step processor. I don't think there's a single node in here we're not going to have to modify. Let's see. Actually, by the way, guys, I forgot. So this week coming up, hang on one second. Let me see. Yeah, actually, this week I'm going to be in Jason Haddix's class for... Which one is that? Hang on. It's Arcanum Security. I misspelled that horribly. But it's his, like, I think he called it Red, Blue, Purple training. Yeah, here we go. So this is the one I'm going to be taking here. It's kind of funny because it's December 3rd and then December 5th. So it's a Wednesday and a Friday. I was like, why not just do like Wednesday, Thursday? I'm going to ask about that. He's like, any questions? Like, yeah, why is there a skip day in between here? I'm curious about that. But it looks like a neat course. A couple of my other coworkers are going to be taking it. So I'm looking forward to it. I'll let y'all know what I learned from it and what I think is really cool and whatever else. All right, let's see. These two nodes, I think, should be largely unaffected. There might be one more change we're going to have to make over here, which is in the step processor. I think is going to need the option to completely bypass this. So what happened now is the processor came up and thought, hey, I've already done this. What do I do? Let me do that. And it said it thought it was already done. So then it immediately routed to the revisor down here. So that might be another thing we're going to have to do. Let's pull up. Let me just pull up a scratch pad here. So from this, what we're going to need, let me just think about this. Okay, so we're going to have to, for the planner, we're going to need to change function to generate. Actually, first thing we're going to have to do is we have to change the structure. Change structure of the exploit steps. So we're going to want to do that. And then in the planner, we're going to have to change the function to instantiate exploit steps. And then in the processor, we're going to need to modify all changes to the state table. That's going to suck. For those exploit steps, because they're going to change exactly how they work. And then, let's see, the exploit step update. Yeah, we're going to have to change that one too. So the exploit step, let's call it update. So in the update node, again, we're going to have to modify all the changes to the state table. And then finally in the revisor. For this one, we're going to send it the entire exploit task list. So modify sending entire exploit step list for the exploit task. Yeah. So I'm just bootstrapping out what we're going to need to do here. So once we modify all the steps and all the tasks for this one, and then we're also going to do this again. We're going to modify it. We're going to updated list of the exploit tasks, exploit steps. So we're going to send it the entire array of steps, and we're going to let it have at it and send the entire list of steps back. So we need to change the structure of the exploit step. Anything else I'm missing? Let me see. So we're going to combine these two. So these two are kind of go away. And they're going to get combined into a scratch pad, which is going to be basically just a string. And we're just going to append onto it. So it's going to become like a running log of what we've done. This, I think, the current step integer. Are we going to need that? If we keep that this is still a list of exploit steps here, I think that one probably... I'm not sure about that. Yeah, I'm not sure if we're going to need to keep that one or not. All right, well, let's start working through this, and then we're going to see where the code breaks. It's going to work or it's going to hit a recursion limit. Dude, it's already practically trying to hit the recursion limit right now. I mean, right now, I really feel, Gumby, that the problem is that this structure is far too rigid, and we're not giving it enough. We're not giving it enough ability to be able to make these changes. And so, if we want it to be able to come through and say, "Hey, here's our exploit steps," and we want it to work like this, we've got to come through and make these adjustments to it. There's so many different ways people are learning now. I got a Microsoft AI cert that went obsolete before I even took it. Oh, bro. I know everything's changing on it so incredibly fast. What was up is now down. What was blue is now green. It's crazy. It changes by the day. I haven't looked at taking a class like this before, so it's definitely going to give me something to think about. Honestly, I didn't even know the course existed until one of my coworkers told me about it. And I have a yearly professional development budget. So that's why I decided to take it, because I hadn't spent any of it. This is usually what I do for my professional development. Is I come in and I work on HackBot, because this is the kind of stuff that my clients are going to start implementing. Not agents necessarily to go play, Hack the Box or CTFs or anything, but they're building these agentic systems. And I was trying to get a better idea of what they're building and what roadblocks the devs are going to run into. So I'm sure you all saw Shai-Hulud 2.0 that just happened, which was the second NPM worm, the resurrection of Shai-Hulud. What happened with that, though, is the initial infection vector was actually a GitHub pull request, if you didn't know that. So I forget the name of the repo, but it was a code base where if you submitted a pull request, it instantly kicked off a GitHub action to do a test build and see what happened. Well, what they did is they put in a script into that GitHub, into that pull request that was an NPM pre-install script. And when it fired, it basically stole all the secrets out of GitHub. And when it did that, it gave them access to the repository. So then they went through and were able to get into the repository and basically make that the initial vector for the worm. And so then it did pretty much what it always did with Shai-Hulud, with the original Shai-Hulud, where it ran truffle hog, it scanned for various environment keys and variables from files, and then it just went about its merry way and continued propagating. All right, let's go hit this. Let's do it. I'm going to move this over to my other window right here. So the very first thing we're going to do is we are going to change the entire structure of the exploit step. So for our exploit steps, we're going to comment these out. And that's going to start breaking stuff immediately. So we're going to keep the step task. We're going to keep the status. But then what we're going to have is we're going to have a scratch pad in here. And so the scratch pad, we're just going to make that. Or make that a string, just like that. Actually, what I want to do there is... Actually, I'm going to make that an annotated. So we'll make that an annotated, and this is going to be a string, and then we'll do our description, which is actions and outcomes taken to complete the this exploit task or exploit step. Got to keep the verbiage right. So our step task is going to be a string. Actually, I kind of want to change that to annotated as well. Let's do that. So make that an annotated string as well. And this is going to be the action to complete. We'll say for the exploit step right here. Boop. So we'll get this up and running. So now we're going to instantly start breaking things when that happens. So let's come up all the way to the planner. Let me take that breakpoint off here. All the rest of this hasn't changed yet. Let's see, where is our planner? There's our router, here's our planner. Okay. So the planner goes, makes its language model call, comes back, and we append 2 additional tasks for this, but it's this create exploit step that we're going to have to go modify. So this is going to be our tool and our output. So both of these are going to get commented out, and we're just going to put in scratchpad equals just blank, like that. All right, so now we've got our status, our whatever our step is, our status, and then bam, our scratchpad, just like so. So after we get that, that actually should be good there. Now the processor is where it's going to be a pain in the butt. Let me take this out because we're not going to be worried about that. So now the question is, do we want to keep this value right here? This stays the same. All the rest of this pretty much stays the same. The question is, do we care about this integer right here? I think we actually have, didn't I make a function for this? We have one for get current exploit task. We could easily duplicate this to tell it to get current exploit step right here. Let's do that. Let's go ahead and add that into here.
Caution. A virus has been detected.
Griffin
Hey, Griffin!
in the network.
What's up, brother? Welcome in, Raiders. Thank you so much. Dude. We found out that our agent is being stupid. Actually, it's not really the agent's fault for being dumb. It's just what we're doing. Hey, brother. Hope you've been doing good. Hope you had a really great Thanksgiving, man. I had a really good Thanksgiving, but now all the kids and the wife are sick. And I think I'm trying to fend it off currently. But welcome in, Raiders. I am not nearly as good as a developer, I'd say, as Griffin. He's probably like a level 99. I think I'm probably around a level 7, right around there. But that's not what I do for a living. I'm a professional red teamer and penetration tester. I get paid to go hack into companies and tell them what I did. And it's a lot of fun. But we're building a little AI bot to go play hacking challenges called Capture the Flag games. And we're having a lot of fun with it. And recently, we had a chill Thanksgiving. Good, man. Dude, that's all I wanted. I wanted a chill Thanksgiving. There's an indoor water park here in town, and I took the kids to it. And my wife's like, hey, you sure you don't want to go down some of the big slides with our older son, codename Agent Zero? And I was like, not really. I'm having a good time watching Honey Badger, my younger son, who just turned 4. I'm having the best time just watching him. I'm chilling over here. I'm standing in the little kid area and just watching him go run and explore and have the freaking time of his life. That's all I wanted. I didn't care about thrills on the slides. I was just having a great time watching him have a great time. And that was good. It was great. So, yeah, what we're doing right now is we've got a couple of data structures in here that were good in theory, but in practice, they're too rigid and it's messing up the agent. So what we have is, for our agents, just to catch everyone up who came in, we've got our tasks, and then these tasks get passed down to primary agents. So like recon and enumeration, and then finally exploitation. And then for those exploit tasks, we have one where it's trying to get a web shell on a PHP server. And these tasks get broken down into an actual exploit task, where it can say, okay, I think the system's exploitable this way, let's go explore it. And then that exploit task gets broken down into a series of steps. Well, the problem is the steps are a little too rigid and the tracking for them is a little too rigid. So what we're doing is we're redoing how this data is structured to make it a little bit more freeform, to give the agent a little bit more agency. Because we have this balancing act we're trying to do, where if we let it do anything at once, it has a very good chance of just going off into way far left field and just losing its mind and getting nothing done. However, if we give it too much structure, then it doesn't know how to act properly. It loses context. It doesn't know what's going on or what has happened. So what we're doing is we're redoing these data structures right now, so that way we can back out what's happening. We can give it a little bit more freedom as it's going through this. Because currently what happened is during our test run this morning, it's freaking 9 o'clock at night here in my town. What happened is it went through and completely lost track of what it had done and started doing things in cycles, but certain parts of it saw that it was already done. So it's not tracking what it's doing very well. And part of that is because of this rigid structure. So we're going to make it less rigid. We're going to make it a little bit more freeform and see if it will be able to have some fun with it in here. So that's what we're currently kind of working through right now. This is an outline, by the way, if you want to see it. What happens here is our exploit agent says, hey, let me go do this. I think we can exploit this system in this way. The step planner goes through and creates the list of steps we need to do. And then this loop right here is the actual execution and error correction that happens. So it comes through and says, okay, let me look at the step. I'm going to either call a tool or I'm going to pass it to a special agent. And then it finally takes all the output, updates it into the state table, and then sends it to a revisor here. That's job is to say, okay, was it complete? Was it not? What's happening? And it lets it go through with it. So what we're doing is we're making it so that it's a little less rigid, and the exploit step revisor is going to have more authority to change those lists of steps. Currently, it was restricted basically to just working on a single exploit step at a time. Now it's going to be able to look at the entire list of steps, get a broader context, and restructure that list and make changes to it. So that's what we're currently implementing right now. So let's go over to the planner here. Actually, I got to work on this guy real fast. Function name should be lowercase. All right, fine. There we go. Will that make you happy? All right. This is just a little helper function to tell us where we're going with everything. Let's see. Get current exploit step task. So what we're going to do is we go down to, we go to the current task, we go to the output. Yeah, actually, this is good, because then what we'll do is we'll return this, and then we'll say, basically, once we're looking at where it is, we'll say if that element has a status of working, then we'll do another for loop. We'll say for, I can't do index. Actually, am I even using this index in here? Actually, yes, I am. I'm returning the index in here. So I don't care about that. I'm going to return this. I'm just going to get the element back. And I don't need to enumerate that at all now. Just like that. There we go. So we'll get each of those elements there. In fact, let me rename this. So rather than this being element, we're going to call this our task here. And so if the task is working, then what we want to do is we'll say for index and step in, and then we'll do enumerate. And the thing we're going to enumerate is this task element here. And what is that value we need? We need the steps in there. Oh, undo. There we go. Yeah, so if the status is working, then we're going to come through and we're going to get the list of the steps right here. That should be fine. Yeah. Why are you complaining about this? Expected an iterable string. Got a literal new working failed exploit. That's not how this works. Yeah, that should be fine. We're going to get the list of steps in here. We're supposed to get a list of steps. I think I'm right and it's wrong. We'll see. Because what we're going to check now is we're going to check the steps in here. So we'll say, we're going to look at the step status value right here. So if the status of that, yeah, if that's going to be a working one, then that's what we're going to return. So this is going to get us the first current working step in here. We'll say that, and then if that's the case, we're going to return index, just like that. There we go. So this will drill down into our state table, because we have a list of our tasks. This is just indexed on whatever the current task that we're tracking is. We look at then the output of it. Yeah, that should be good. Oh yeah. Not sponsored by Jocko yet. Working on it. Let me change this one too, because I want these to kind of mirror each other. So if the task status is working, that's fine. We could actually even call this one right here. I tell you what, let's do this a little bit different here. So let's do let's just bring this up a bit here. Actually, I'm going to take these out. I'm going to de-index these right here. Yeah, let's do that. Let's do current exploit task is going to be this guy right here. And then we'll pass in our entire state table. We're just going to do it script here. I'm going to copy this real quick. So we're going to enumerate that, and then we're going to index that on our current exploit task. Just like that. There we go. So that's going to give us our step. And then we're going to find the first working step. So we're kind of, we're referencing this first one up here. So this gets us the first current exploit task. This gets us our first current exploit task step, which is nested under it. And then this will get us it back. Okay. There we go. Excellent. I think that will work. Because now we can use this to help clean up some of these things. Since we need to go back and work on the processor anyway. Let's take this. So our current step, this is going to change right here. We're going to take that and pass in our state table to it. That should return our integer. And it's complaining because we haven't imported that yet. So we'll import that. Yep, there's our current step. And then we look at our step task right here. And then we build out our prompt. Excellent. Okay. Actually, were we even using the working memory? I don't think we did. Let me look at the last trace we just did here. Let me bring this down. Let's dig into the state table real quick. So go down to our exploit task. Actually, we don't even need the exploit task. Working memory should just be in here. Yeah, so we're not actually using the working memory. I'm fine with that. We don't necessarily need it. skip this. Put that as the list to delete it. All right, so here's part we're going to have to actually go through and change. So this right here, this is actually making the language model call. And we're looking to say, okay, do we have a response of special agent caller? So after it makes the language model call, it's going to be given a list of tools, right? So let me come up here and I'll show you an example. So this was our first test run for the night. So when we run the step processor here, here's a list of all the various tools that it could use, right? So it could try and do a Python exec, a SQL map. It could try and get a PHP artifact, since we're doing a PHP exploit. All these other ones in here. It can also call the special agent caller. So this is a special case where the special agents are subgraphs that don't appear in this view. But that's what's happening when it hits this node. It's actually passing off to a subgraph that's just not rendered in this view. And the one only special agent that we have right now is one to work a browser for us. So it gives it a full Playwright browser inside of a Docker container that it can use. So we bring this over. So I'm going to need to modify this. Actually, this part can stay. It's this line that's going to need to be duplicated. There we go. So this is the part right here. So we've taken out the tool part and we've added it to the scratch pad right here. Let's see, when it called that, what did we actually get back? Another issue we're kind of contending with, it's not a big issue, it's just a change in design for the way Claude operates. So we're doing the testing originally against Claude 3.7. We recently switched to Claude 4.5. Claude 4.5 doesn't like to give a ton of information back sometimes whenever we are working on this. So what I want to get is I want to get this message and the tool call right here. And it's kind of hit or miss which one is actually going to return what it did in here. So we do want to capture that though. So basically we don't want to take the entire message. We want to take this part and the tool call, and we want to append those over to the scratch pad. And if you're wondering, why do I have this huge long line here? It's just a design decision. So up here, you notice that we actually pulled out a bunch of variables to help out with stuff. Like we go get the current task, we get other stuff like that. All this is really good, but when we get ready to make changes, we actually have to return the changes from this function that says, this is what we're doing. In fact, I backed up too far. Here we go. This is a better example. So it's like, hey, we got all these helper variables. Why don't we just modify those? It has to do with how the data gets returned in LangGraph. When we get down to the return step, we're actually going to return the updates to the state table and let them get merged in. So what the kind of design pattern that we're following here is that for anything that we're just reading and referencing, we'll pull out into these kind of comfort helper variables. However, anything that we're getting ready to return, we're going to modify the state table, and then we're going to return those keys for the state table. So when we get ready to return those, that's what we're doing right here. So we're modifying our copy of the state table before we return it back. Let's see. How do I want to get this back in here? So we are tracking the entire response from the messages. This is going to be an AI message. I got to remember what's the structure of this. Let's see. LangGraph AI message. Where's the documentation for this? This is LangChain. This is not what I wanted. Well, I guess technically, actually, it is a LangChain AI message. LangGraph doesn't have the concept of talking to and from the agents, or to and from the language models. That's all handled in LangChain. So yeah, this should be. All right, messages. AI message. Here we go. So we have tool calls. Let's see. User metadata. We have our type, which should be type AI. Where's our methods, though? Oh, wait, hold on. Got this browser over here I can use. Returns a pretty representation of the message for display. I might try this. I actually don't know what this actually looks like. Let me see if anybody's got an example of that. Let's see. LangChain AI message. What does this actually look like? Somehow we got Helldivers in here. That's not what I wanted. I want to know, does this actually return back the... Because this is kind of a weak description. I want to know if the pretty representation actually returns the tool call back with it. If so, maybe we can just use that. I don't like the way this is structured. Basically, what this was doing is looking to say, hey, are we calling the special agent caller? Which is represented as a tool in the list, and then it would call the subgraph to call the other tool. But I don't like the way this is done. I think I might just redo this entire thing, because it seems like it's wasted effort in here. Yeah, I think I just want to use this version of it right here. Let's do that. So first thing we're going to do is we are going to change this. We're going to change this status to working. Actually, I take that back because there could be something changing with this. No, I do need that. So we're going to change that to working. And then what we're going to do is we're just going to come in and use this option here. Let's call this our scratch pad. So we'll make that a string. I can't type. And we'll make this a format string. So this is going to be our response dot, I think, text. Okay, that is not what I expected. Oh, it's because I didn't type this correctly. So this should actually return. Yeah, this should return an output value in here. Hang on, let me go look at this definition here. This was a wrapper function we did. Yeah, LangChain output. Okay. Is it going to work or did Blaise break it? I'm going to vote broke it. I'm going to even vote broke it because I know me. I'm not a professional developer. I've spent a lot of experience breaking code and working with it, but actually building code is not something I'm super, I have a lot of experience with. So that was one of the reasons why I started this project, was to learn how to become a better code writer. I'm used to reading code, dozens of languages. The only language I've ever had trouble reading is Rust. So I have a special distaste for Rust. But other than that, reading code and modifying it and hacking on it and finding bugs in it, no problem. Writing it from scratch, not a lot of experience with. So that was one of the main goals of this project. It actually had several. Not a crab. Dude, I saw this. Have I tried anti-gravity? Oh, is that the that was the new hold on. Before I start running my mouth. That was the anti-gravity IDE, right? Yeah, Google's anti-gravity. I have not. So I purposely made the choice that I'm not going to use I'm not going to use any, but I'm going to use as little AI coding assistance with this as possible, because I feel like using that too early in the game is going to be detrimental to me. So instead, what I've decided to do is, unless I hit a problem where I really just don't know how to structure it, I will go throw the information over into some language model, Claude, Grok, whatever. Those are usually the two that I use because of just the two that I have access to. I'll go run it through that and at least get an idea of how to structure it, and then I'll write it myself. The only piece of code that's running in here that is working that I did not write is the actual browser agent, and it doesn't even run super well. It's very, very inefficient. It's on my to-do list to go rewrite the browser agent eventually. Anti-gravity is free right now. It's not so much the cost of it, it's just the idea of I want to be able to think about these things and flex my own neurons. I have a feeling that what's going to happen with a lot of the AI stuff is people are going to kind of flood into it, and you're going to have this distribution of people that don't really know what they're doing, but they can make things work with the AI stuff. And then you're going to have people that know what they're doing and can do really awesome things with the AI stuff. So basically think of it like a force multiplier. And the problem is it's going to create this gulf in the middle where it's almost like these two quantum states, and you have to try and force your way over into the other one. And the only way to do that is by actually learning what's happening and what's going on, and not just vibe coding the entire setup with it. So that is the path I'm taking with that kind of thinking behind it, is that I'm doing this so that I can build my own neural pathways. I can let my brain evolve. I can do this better and understand what's happening. And then I can do it faster by bringing in something like anti-gravity into it. Yeah, exactly, Gumby. This is a project to learn how to develop the bot, not to have a bot develop the bot. Yeah, exactly. I am more of the camp where this should be stuff that's augmenting people, not replacing people. Oh wait, I was actually doing this up here. So from this response, this should be... Actually, I'm just going to say this is going to be an AI message. That's exactly what this should be. So if this is an AI message here... There we go. So we could get our tool calls, we could get our name, type, content. I believe content is what I'm going to want. Yeah, just like that. So we'll get the content out of it, and then what we'll do is... We're going to do another one. We're going to say the response dot tool calls. Yep, tool calls, just like that. And in fact, I can even still do this right here. Yeah, actually, we can do that. Let's do this. We'll have a little piece of code actually run here. We'll say if it's special agent caller. No, that's not what I want to do. It's still going to make it a really long, annoying line if I do that. Actually, yeah, hold on. We can do this. Let's do that. We'll do response content. We'll say if this, then what we're going to do is we're going to actually, how would this work? It'd be an if function, right? So what we'll do is we'll say, would that be a return? Actually, I don't know about that. Let me see. No, I just want this part right here. Thank you. Actually, I don't know why I'm doing this. Hold on. That can just go away. We don't need that because the response tool calls is going to say, hey, we're calling the special agent and we're doing it this way. That's easy enough. Okay. I don't even need this. Let's bring this back up. Let's back that thing up. There we go. That's our scratch pad, just like that. Boom. So then we can take all this crap out. And now, actually, this needs to change because this is not going to be whatever our current step is. This is it's not going to be our tool section. It's going to be our scratch pad. So we're going to pull out the old scratch pad. And that's going to be our scratch pad, just like that. Boom. I like that a lot better. In fact, I'm going to just get a little ballsy. I'm going to delete that out. I'm going to clean it up a bit. Eventually, once everything is kind of working, once we finish these agents up. So right now, currently, here's where we're at. If I come over to Stinger. Recon and enumeration, they're done. They were fairly easy. Exploit is fairly complicated. There's one more that's going to be over here for post-exploitation. That one's going to take a lot of effort and work because we're going to tie it into a command and control system called Mythic that's going to allow us to basically do more advanced stuff with it. But then after that, there's actually still one agent we have to work on, which is Stinger, which is the supervisor agent. This right now is pure code. It doesn't do anything. No thinking, no language model calls, nothing. So once we get post-ex done, we're actually going to come back over to Stinger and work on Stinger. Once Stinger is done, and somewhere in there, we're probably actually going to need to spawn a some kind of a user interface for handling certain interactions, but I haven't figured out how I want to do that just yet. But once that's done, we'll actually come over and we're going to pause all the development of new stuff, and we're going to go through and clean up all the code that I wrote as an idiot, because I've been learning a lot of Python. We've been working on this project since about February. And so there's better ways to go through and do this. So we're going to take all this and we're going to do a complete code cleanup of everything before and try to make it more scalable, more expandable, easier to work on. And then we'll start adding new functionality once it finishes this very basic example. Just comment it out. No, delete. Be gone. Because this is essentially doing the exact same thing. All that code was looking at was it looked to see, did we call a special agent and then make it special like that? And I was like, we don't need that. Remove redundant parentheses. Did I have parentheses in here? Oh, I don't know why that. Oh, it got put in there because of the line return. Okay. All right, so there's our scratch pad. What we're going to do, we set it to working. We set that to here. Now, why is this? Okay, cool. Now the type checking is actually working. I don't have to have the type checking ignore in there. This actually might throw an error because there is an edge case where the step processor will not actually return a tool call. But it doesn't happen very often. When it does, we'll actually go through and see, do we need to maybe do an if check on this? We'll find out. That was actually a lot easier than I expected for the processor update. But now we actually need to go down to there's our special agent node. There's our step update. The tool node is a kind of a pre-built-in one that makes it kind of easy to execute the tools. Those all get executed in Docker containers using robo pages, so it's not such a big deal. No regrets. No regrets, Gumby. No regrets. I probably will regret it, but that's part of the learning process. So I'm a system analyst working in Oracle Fusion, and honestly, SAS feels like it's on life support. So I've been building agents for tasks like data validation and shadow processes and mapping out our entire workflow with a multi-agent setup. Very cool. So I just went from knowing Python and SQL to outpacing folks who are focused on only one piece of the AI stack. Nice. Nice. That's actually one of the things I'm looking forward to learning from that Jason Haddock's course. Let me bring that back up. So for everybody who just popped in from Griffin's stream, this is a course I'm getting ready to take this coming week, and it looks really cool. So here's the syllabus in it. So we're going to kind of go through some AI history, MCP and security, chat interfaces and APIs, playgrounds. But prompt engineering is something I'm curious about just because I don't do a ton of it. I keep the prompts in HackBot very light, and then I expand them as required. So we run into an issue. It's like, okay, cool. Let's go adjust the prompt. Let's make it so it handles this this edge case more cleanly, or it follows the rules a little bit more strictly. And then I was curious about how he's got some information here about basically building agents. And so I was curious to see what there is in there. So a lot of interesting stuff coming up in that. It is wild, and I wouldn't recommend taking it, except I'm getting my company to pay for it. All right, so for the step updater, let me see what we need to do here. So there's our task, our exploit task index. What are we doing even? Where are we even using this? Am I even using that value? I kind of am here, but I could clean this up a bit. I think I want to I think I just want to combine these steps in here. Make this very clear what's happening.
Incoming transmission from Mariano Gumby. Yes, Daddy.
Yeah, make them pay. Oh wait, hold on. I screwed this up. Let me see, because what I want is actually this. From the state task, current task. Right here. So from the current task, then what we want to get is... Yes, there's our task. And then over exploit task index. So we go to... Yeah, we're going to index that on current task. That's no problem. That one we can keep tracking. And we go to the index. Did we keep the current step in here? And the exploit step? In the exploit task. Actually, yeah, we did. God, this is all spaghetti code a little bit. I build agents that analyze my prompts that know the context of the project, and it's helping me build the prompt. So I've hit the prompting engineering angle hard, but then realized AI was better at it. I will do that too. In fact, we did that a little bit with Grok, because that's the one I've been testing out recently. I think it does a pretty decent job. It's very, very fast. However, I don't know if it does a heads over tails better job than, say, Claude. And I just haven't used Gemini and OpenChatGPT very much. I just haven't used them very much. Why? I don't know. Maybe I'm a hipster and I just think they're too cool. But But yeah, actually, I do think that's, and I have a particular reason for why I will do that with the language models and use them to write prompts. And it's because if you think about it, all the vector analysis that's happening should be fairly similar amongst them, right? So you're giving it information about what you want and what you've got, and it should be able to use that to kind of vectorize and go through and think about it. If you think of everything in terms of you're trying to find basically keywords with instructions in a hyperspace of vectors, and you want to try to drive those vectors in a particular direction, or at least restrict them and cut out certain pieces of the vector space, and you do that by the wording that's used. Well, who kind of understands the vector space the best is a language model. So that is one area I think it's super handy to use for AI assistants, is actually for building those prompts. I think I'm just doing this all completely wrong. And what is this? 6 a.m.? No, we're going to delete that one too. Too many chirping birds. Speaking of vectors, have you seen Google's new file search? I have not. Let's go take a look at it. So Google, the Gemini API enables retrieval augmented generation through the file search tool. File search imports, chunks, and indexes your data to enable fast retrieval based on a provided prompt. Information is then used in the context of the model. Okay, I mean, I've done RAG before, but that's cool that they've got it kind of built into their platform. Eventually, I do want to build a RAG system into HackBot, but I want to do it in such a way that the data stays partitioned, if that makes sense. So for example, there will be information available to the exploitation agent. The special agents, eventually I want to have an ability where they can send pieces of information that they can have in a RAG pipeline that can then be ingested and searched against. But I don't want the entire thing to be one giant RAG pipeline. I've run into that with OpenWeb UI. And the issue that you run across whenever you're doing that is you get too much data to kind of search across in there, and you get too much vector similarity. So if one of the keywords that it really focuses on in that vectorization of your question happens to line up with something in a completely unrelated section, you're going to be pulling the wrong context out of the RAG pipeline. So rather than having it be one giant bucket, I wanted it to be individual buckets of specialized knowledge that we can then pull from. I gotta remember what I was doing here. Let's see. Let's do this. Let's do exploit step index. We'll make that an integer. And we're going to say get current exploit task step. And we'll pass in the state table there. That's going to make this a lot simpler. I'm going to take that out. And we're going to break some stuff when we do it, but that's all right. So I don't care about updating the exploit task. Just specifically, what I want is our exploit step. Let's make that an exploit step, and for that we're going to get that out of the state table. So we'll go to it's going to be in tasks. I don't know why I'm having so much trouble typing. I think I need to readjust my keyboard layout here. And then what we'll do is we'll go to this one we will use here. So we'll use this part. We're going to get whatever the current task is, because this is going to get us our task. Exploit tasks are nested under that. So once we get the current task, then we want to get our, we want to index that on our exploit task index. And then we're going to index we're going to access the output from that. Oh, should I take that back? We need to get the output from here, because that's where it's nested under. So we'll take the output, we'll index that on exploit task, and then we're not going to take the output from that. We're going to index that on the exploit step index, just like that. There we go. Actually, I take that back. We have one more in here, which is going to be our steps. So we got to do one more. So we'll do our steps just like that. Okay, cool. So now we have our exploit task, our exploit step, just like that. Yes. There's so many different ways to do these things, it's hard to keep up. I know, man. That's part of the reason why I was like, I need to go write something for this to kind of keep track of everything. I gotta run to the bathroom, guys. I'll be right back.
Caution. A virus has been detected.
Marcelo_Devsters virus detected in the network.
Alright, back. Guess who's back? Back again. Shady's back. Hello, friend. Hey, Marcelo, what's up, man? Wait, hold on. Did we have a course we raided as soon as I waited to go to the bathroom? What's up, guys? Welcome in, Raiders. My name's Blaise. Thank you for coming in. Hold on. Marcelo, what were you working on, bud? Of course. It's like the perfect timing. Also, I went to go check on my wife because she and my 2 sons are currently all sick. And I found her playing Beat Saber in the other room. So I think she's doing all right. Oh, let's see here. So, by the way, everybody who just came in on the raid, welcome. I hope you're having a fantastic Saturday. My name's Blaise. I'm a professional red teamer and penetration tester, and that's what I do for my day job. And then here on stream, we're actually building out a little AI hacking bot to come play hacking challenges called Capture the Flags. So we're currently working on an exploitation agent that's job is to take information from our recon and enumeration and then find a way to exploit the target. Hey, Jerv, no problem, man. Dude, I love teaching. It kind of runs in the family, except I didn't want to be like a public school teacher. That's a very, very difficult job. And so I've been in IT for 15 years now, getting on towards 16, and just having a good time with it. I've been in offensive security for 7 years now, getting close to 8 years. Damn, a long time. So, and the reason I started this whole project is because I needed to learn more about agentic systems because I knew my clients were going to be implementing it. So I needed to understand what it was doing and kind of how it was operating. And the other reason is because I actually kind of suck at writing code. I've read and hacked on code and modified it a ton in dozens of languages, but actually sitting down and writing something from scratch and expanding a code base and having those challenges, I haven't really done. So I wanted to become better at writing code and crafting it and learning about it. So we don't actually use, ironically, don't use hardly any AI to help write this code, except in some niche circumstances. I'm basically just writing it all because we're going to come in and we're going to have some fun with it. All right, let's see here. So currently what we're doing is, let me bring this up real fast. So this is the basic outline of our overall agent here, where it takes in, Stinger is our supervisor and it hands off to these different, what we call primary agents. So we're currently working on the exploitation agent right here. Or is it exploit? Here. And so let me move this stuff kind of out of the way. So this is the primary loop for our exploitation agent. Once we identify the target and we think it's exploitable, the exploitation agent will then say, hey, I think it's exploitable in this way, passes it off to the step planner, who then creates a plan of what steps to go execute to attempt to exploit the target. And then it runs through this loop to try and see if it can make that work. So it will go through several iterations of it with doing error correcting to see if it can come through and get a successful exploit on the target. Currently, we're using a very, very basic web shell with a very simple bypass. So it's a PHP server. We need to upload an executable PHP script on there to get our code execution. However, it doesn't allow any files with a .php extension. So it needs to understand that it can use .php5 or .phar, some other extension that's executable by PHP but doesn't match .php on the end. The problem we're running into is everything was kind of very strictly structured in here. So we have this nested list of tasks in a state table that tracks everything that's happened in here. And under these tasks, we had 2 specialized types. We had an exploit task and we had an exploit step. And these actually formed what should have been like an ordered list of steps that need to get taken. However, it wasn't quite operating very well. It wasn't thinking about how do I really need to come through and modify this and take a look at it. So what we're doing right now is we're actually making it less structured. So we're taking some of these data structures and we're combining them and we're making them a little bit more raw text rather than like strictly structured information. And then when we do that, we're going to take it and let the reviser here see more of the data that's happened and be able to take better action on what's been going on. So that's currently what we're doing. And in fact, I know I just realized something that we're going to have to do, which is the context builder is going to have to change, because on these steps, we're taking out these two fields right here. And originally what the context builder did was it looked at these two pieces of information and essentially zipped them together to make the output. That's not going to work anymore because they're now just a single scratch pad in here. So not a big deal, but that is something else we'll have to go update. So currently what we're doing is we're updating this one right here, which is the updater. And this basically just updates information about whatever tools were called and puts them into the state table. And then the reviser will come in and say, all right, what do I need to do? Did it work? Did it not work? Do we need to make adjustments to the plan? Things like that. And then it will pass it back over to the processor. And it runs in this loop here. Hopefully until it gets successful exploitation, in which case it kicks it back up to the exploitation agent. So what we're doing is we're currently doing a bit of a rewrite to make it less structured. It was a little bit too rigid for the language model. It was messing up the task list. It was doing all sorts of other janky stuff. So we're going to give it a little bit more agency when it's operating in this. We don't want to give it too much because then it just starts going down really weird paths and doesn't know what to necessarily do. The context can get really large and that causes all sorts of other issues. So we're trying to keep everything controlled, but not so strict that it can't operate. And that seemed to be the problem we were running into, is everything was too strict and it was too clamped down. So yeah, we're currently working on this update node right now. Let's see here. So we have our exploit task and our step index here. Do I actually need to do it this way? I don't think I do. I don't think I even need that. I'm going to just comment that out. And come to think of it, I don't think I even need this one right here. Oh wait, I do need the exploit task index. I just don't need the actual exploit task itself. I just need this step in here. So we're going to get the last message in here. We're going to say if it's a tool call, which it should be. Yeah, there's one other thing we need to do in this. So you see these dash lines? Those are conditional jumps, and there's actually a hidden function that happens kind of right in the middle here. So when the data exits the step processor, it goes into another function that says, okay, what node do I need to go to next? And so we've got two options, the tool node or the special agent node here. There's actually a third option that should happen, which is if we don't have any tool calls, it should actually skip this and come down to the update directly. And that might be because maybe the step processor says, hey, I don't know what to do, or it thinks we've already done it and it could bypass it. I do need to make that update. I'm just not going to do it at this exact moment. We're going to assume that it's always making a tool call. Okay, so then we're going to append the tool call output. So if the last message type is tool, it's going to take out the tool output. And this is going to have to change here because we're not going to take, let me see. That was our current step. That was weird. Never dinged like that before. All right, so here's where we get the actual tool output. What we're going to do is we're going to take this and let's see. So there we get our tool output. We're getting basically this AI message is just a tracking message. We're going to take the state here. So we go to task, current task, go to output, the exploit task index, steps, current step, which we're not using. That's going to be our exploit step index. And Yeah, because originally we had an output. So this is not going to be it. This is going to be our scratch pad. And we're not even going to append this. What we're going to do is we're just going to do plus equals our tool output, just like that. So we're going to take the tool output, which should be a string, and we're just going to add it onto that. In fact, this might seem kind of silly, but for formatting's sake, to make this a little bit simpler to track, I'm actually going to make that a format string. There we go. So we'll format that out, and then boom, that should be good. So now, rather than, we used to track everything in tools, like what were our tool calls and what were the output for those tool calls. So they're basically one-to-one lists. Instead, now we're just combining this into a string for the scratch pad right here. Let's see. I think that's all we need to do on that one. Yeah, so we've modified the updater, and then now we need to modify the reviser. And this one, what we need to do is we need to send the entire exploit step for the exploit task. Okay. So we're using the working memory, but are we actually using the working memory? I don't think we are. We use the working memory down here a little bit. I liked the idea of the working memory. I just don't know if we actually need it. I'm going to leave it in for now. Let's see. So current task, we're going to... That's fine. Our task, which is going to be... That's going to give us our current task. And then we have our exploit task index. Ooh, do I want to do it that way? Let me think about this. This is going to look janky whenever we run this. Oh no, did it die? Oh, it didn't. Sweet, I can add another hour to it. Quick pro tip, by the way, whenever TryHackMe's interface is a bit janky, so, and it's logged me out in the middle of like working on these boxes. So this is the example we're using, RootMe, which is a super, super old and simple one for this test case. Like I said, we're just trying to make it work first, and then we're going to start adding additional functionality. But whenever you're in here, when you come to TryHackMe and you boot up your machine, you're given initially 2 hours to work on it. I've had it log me out in the middle, and I hit the add an hour, basically so I can have another hour to work on it. And when it does that, it just updates the UI and doesn't actually update it, and the box has died on me. So what I will always do is add an hour, and then I'll refresh the page to make sure it didn't log me out. I can actually go add the extra time. Hey, Mitch, what's up, man? Welcome in, brother. Happy Saturday. All right, so now that this is running, let's come back over to the code here. So what we're going to do is we're tracking our AR messages. We get our current task. We get our exploit task index. And you have to remember, because the way this is set up is if we come down to the state table, we have these tasks here. It's a list of these tasks. And that's this data object here. But then nested under this task in the output field, we have this guy right here, which you can't see because my fat head's in the way. It can be an exploit task right here. So when we do this, we actually have exploit tasks, then we have exploit steps that come in here. Are you doing malware analysis? Not quite. What we're doing is we're building an AI hacking bot to go play things like TryHackMe and Hack the Box. Because for multiple reasons. One, I suck at coding. I do code, and I've done a lot of code analysis and breaking and modifying of code, but not writing from scratch. So I wanted to get better at it. And two, a lot of my clients are implementing these same kind of agentic systems in their environments. I wanted to know kind of what was the design decision some of these developers might go through, so I would know how to break it more efficiently. So we're building it so we know how to break it. And there's going to be some other really cool things that come across from this The special agent system that we've implemented is kind of like a plugin where you can take it and basically drop it into this folder here, special agents. And I'll go through, it's working right now, but I haven't defined the structure of it very cleanly. And the special agents will then have the ability to augment what's built into HackBot here. And we can see it here in the graph. So what happens is it basically acts like a tool where when we get ready to call something, we can either call a tool node or we can call a special agent. And these specialized agents can do different things. So the only one we have built right now is one that handles browser interactions. So it creates an entire Playwright browser inside of a Docker container, and we have full control over that. So if we need to actually go render something, because most of the time these CTFs, the initial access vector is some kind of a web exploit. So having a browser in there is going to be super handy, especially if it's a little bit more current exploit where the browser actually is doing all the client-side rendering in JavaScript. Can't really do that with curl. So we need an actual browser engine to work on it. So this is the only one that's up right now, but I have so many ideas on updates I want to do to the special agents. I'm just keeping them for in the future. For example, we don't necessarily have to call the browser agent from the graph here. What it does is the browser agent actually builds its own LangGraph graph to actually go run this. And when it does that, it's actually executing a separate workflow. We just don't see it here in the overall workflow. But there's nothing to say that we couldn't actually have an option in here that we could run this directly and have it be like its own little chatbot, where we could have it go through and do things with a browser. That'd be pretty cool. Or, for example, I've got some stuff coming down the pipe I need to work on. I've been saying that for like a year, but I promise I'm getting ready to work on it, where I'm going to be attacking Azure and AWS type systems. So with that, it'd be really awesome to have a specialized agent that does maybe Azure reconnaissance or AWS reconnaissance or whatever in here. And we could have those built in. And then if you didn't want to use it in HackBot, boom, you just go load up the special agent and then you could chat with it. Be like, hey, go find out this information about the AWS environment. Go find out this information about the Azure environment and have it start doing some reconnaissance for you. So I thought that would be really cool to do. I'm super looking forward to expanding this special agent section. Right now, it's just like a minimally viable product working, and it is working, but I can't wait to do some of the extra cool stuff on it. I'm looking forward to that. But we got to get this damn exploitation agent working. Right now, it's a bit too rigid in its structure, so we're actually making it a bit more freeform. We're taking some of the rigidity out of it and letting it just kind of work a bit in here. So we used to track tools and output very cleanly and enforce that it go through this certain particular path. So now what we're doing is we're just tracking everything in a scratch pad where we're just keeping track of the text, what it did and what was the outcome, what it did and what was the outcome. We're just going to track it directly. And then, ooh, that's going to be tricky in here. Come to think of it, because we actually used the length of this list as a tracker to see, did this step just absolutely fail? Ooh, yeah, we're going to have to fix that. That's all right. My Python's rusty. Dude, my Python was practically non-existent before starting this. A lot of my coding was. I was just not writing code. I was analyzing and breaking code. Two very different skill sets. I wanted to be better at writing code. I'm taking a break from my CISSP stuff and pivoting into TryHackMe, actually. Nice! I think TryHackMe and HackTheBox do have pretty decent learning platforms. I do recommend them to folks whenever they're like, hey, where do I start? I was like, go down this path. I think TryHackMe is a bit more guided than HackTheBox. TryHackMe is a bit more guided. HackTheBox is a bit more learn it on your own. They have benefits to both, so I kind of recommend both in there. I'm not in AppSec. I do network penetration tests and red teaming, but I did do a lot of web apps in the past. I'm still really burned out on web apps. I did so many of them. I'm like, if I never did another web app assessment again, I would be perfectly content. Because I've been doing this for 7 years. And I went through and I figured it out at one point. Let me see. So 6 years was at my first my first job. So basically did about one test every 2 weeks with 2 weeks off. So if we do 52 minus 2, that's 50. And we multiply that by 6, and then we'll divide it by 2. So that's roughly 150 penetration tests I did. And probably, I'd say 80% of those were web apps. So I've probably done about 120 web applications over that time. I am just so sick of web apps, man. I get them occasionally at my current job, but it's pretty rare. And so it's not so bad, but it was just constant. I loved every time I got an internal assessment or a full-on penetration test, something that wasn't AppSec. So I'm a blue teamer. I was too for many years, man. I've been in IT for 15 years, but I've only been in offensive security for the last 7 years. So roughly half my time was blue, half my time's been red now. It's finally starting to tip to more red than blue. Hey, Outcast, what's up, man? I'm a SOC analyst for level 1, not sure which path to take my career, so any tips? If you like the work you're doing, then what I would do is do this first. Go talk to who are on the tier 2 and tier 3 side and see what they're doing. And if that's the path you want to go down, start down that kind of learning path. Are they doing maybe more malware analysis or advanced triage? If they're doing a more advanced triage, understand what they're doing. A lot of that you're going to be learning then in that case is, ironically, some more system administration. Because if you don't understand how the systems work, you can't understand how to defend them, and you can't understand how to break them. So it gets to a point where I recommend a lot of offensive folks. They're like, hey, what course should I take next? I was like, do you understand how Active Directory really works? Have you ever set up like an Active Directory domain? And a lot of times they'll say no. I was like, okay, you need to start there. Go set up your own Active Directory in your home lab and actually look at all the different switches that you can do, and then attack it, figure out how to block that attack, and then attack it again, and then figure out how to block that attack. So if you don't understand how it works, you can't understand how to fix it, and you can't understand how to defend it, and you can't understand how to attack it necessarily. So I've been in IT for 5 years. This is my second year in InfoSec, so I'm following in your footsteps. Nice, man. Yeah, it was kind of wild too, because I graduated December of 2014 from university. And it was funny because I graduated on a Saturday, but I was actually interviewing for jobs during finals week. So I graduated on a Saturday. I took my diploma to orientation on Monday to show them, yeah, I do have a degree. It was kind of wild. I rolled like dead into it. But also, I was working in IT the whole time I was in school. It was very, very difficult. If you can pull it off, it is great, because I graduated, funny enough, with a degree in math, but I graduated with 5 years of security experience under my belt. Or not security, I had 5 years of like system administration experience under my belt, working on all sorts of different stuff. Windows servers, virtualization, networking, you name it. I was probably tinkering with it in some way because I was working at a university teaching lab. So we had lots of different areas that we had to support and work on. So I did that for the whole time I was at school. I was really excited actually just to be working and not have work and school, especially since I got married during that time. So it was a lot of work. Black Hills has a really great AD beginner course. Oh, neat. I actually haven't looked at the course offerings from Black Hills. So that's cool to hear. I've known a lot of people that worked at Black Hills, and they were all really smart guys. Universities can expose you to the gambit. Oh, yeah, they can. I actually really liked it because I was always messing with something different. I worked in a lab that was teaching Cisco networking. And in that lab, it was a huge lab, really big. Actually, I got offended at one time because this guy came in and was touring our lab, and he called it a Ferrari lab, or like a showcase lab. Basically saying, oh yeah, this looks really cool, but you can't do anything with it. I was like, it's like, listen here, motherfucker. I didn't quite say that, but I really wanted to. I was like, this lab is wired up so immaculately. I could have somebody in the first row, because we had 1, 2, 3, 4, 5, 6, 7. We had 7 full rows and then 1 mini row, which is where the instructors sat. I was like, I could have somebody wired up and linked from row 1 to row 7 all the way in the other room in about 3 minutes. Everything was interconnected. It was all hot wired. It made it so the students could get in and do their work real quick. And I wired that entire lab by hand, doing all the freaking punch downs, running the cables, combing them out, not zip tying them. We got away from zip tying because we got too many freaking cuts from it. Velcroing all those runs, giant stacks of cables like this. I did that whole lab. And then for him to come and say, oh, it's not really a functional lab, I was like, I wanted to smack him. But we had people come and tour that lab. And we had a virtual lab set up where students could come and remote in and actually work on a full stack of equipment. There were 3 routers and 3 switches. And we had a centralized switch that did some VLAN magic so we could change the topology of where those routers and switches were connected. It was sweet. It was a fantastic learning experience. I really enjoyed it. Oh, by the way, Baggy, thanks for coming online, man. Welcome in. I hope you're having an awesome Saturday. Let's see here. All right, so currently what we're doing is we're updating the revisor portion here. So this is basically our error correction node. So it's going to look at what happened for the step it's trying to do in the exploit process. So the processor says, okay, here's what I'm going to do. It calls whatever tools it wants to try and get that tool, that exploit step done. The updater just updates our state table, and the revisor should look at all the information and say, okay, we're off course, or we've hit a blocker. Here's how we're going to course correct, or here's how we're going to overcome this attack, or fix our attack vector. This is what it's doing. So this is the one we're updating right now, and it was working in the old rigid style. And so since we've expanded its capabilities a little bit, we need to go fix it. I got to remember what I did here because the code is all kinds of chunky. Let's see. So we track our working memory. Let's see. We get our current task. That's fine. We get our current task, and then we get our exploit task index, and then we get our exploit task. Okay. I'm gonna rearrange this just a wee bit to make it more readable. I'm gonna change this actually. I'm gonna take this out, and we're gonna get the current task index and pass in our state table. That's gonna auto magically get us whatever one we're working on. Wait, is that not it? What was this one here? Oh, there we go. I really should have renamed that to index, because it doesn't give us the step object back. It just gives us an integer pointing to that, but it's fine. So then we get our current step, that's fine, and then we build our context. This is the one that actually I was talking about. We'll have to go fix real quick. So this is not going to work anymore. We're still going to need this guy, the build exploit task context. This is a helper function to go basically prepare the context of everything we're going to send up to the language model. Because you have to remember, these language models, whenever you're interacting with something like, for example, and I'm just going to use Grok because that's what I've got. Is it grok.com? I think so. So whenever you're interacting with this language model, you're not actually interacting with the language model directly. This is a web app that is handling some of this stuff, the memory tracking and everything else, and making it look all pretty. And it is handling all of the information that goes to the language model every time you type something in here. When we're making the API calls, though, we don't have that. We have to explicitly build all the information we're going to send to the language model, and those are essentially one-off transactions. There's no memory on the language model side. It doesn't actually remember anything. It's all the illusion given to you from the web app. So what we have to do is we got to go build all the context so we can put the entire language model call together and send that information up to the language. Oh, hey, okay. So HackBot is our little AI hacking bot that's designed to play stuff like Try Hack Me or Hack the Box games. So it's very, very rough in the development. I usually only work on it on the weekends during the live streams. And there's an entire playlist of like what I've done over on YouTube about it. And basically we just go through and we're building it out and we're testing it. Currently, it's a bit too rigid. In fact, here, let me show you. So what we had before is we have tasks that are tracked in our state table. And then we had a specialized version of those tasks that were called exploit tasks. And this was designed that it could try an exploit and fail. So for example, if the recon and enumeration agents came through and said, we think, or here's all the information we have gathered about this target, the exploitation agent goes through and says, all right, I think it's exploitable in this way. So then it builds that idea out and then it sends it to this loop right here. That's not the right loop. Where is it? It sends it over to this loop here. So it says, okay, plan out all the steps we need to perform the exploit, and then it goes through and it actually attempts it here. So each of those exploit tasks can fail, and it's fine, because one way we think it might be exploitable might not be the actual way. So once it runs through that, underneath that we have these steps that are nested. And this structure was a bit too rigid. It was giving the language model a lot of trouble trying to maintain how the steps were actually being done. So what we're going to do here is we're going to update this here. And rather than having it basically return a verdict on what happened to the step, we're going to send it the entire list of these exploit steps. So the revisor is going to send all that information, and we're going to let the language model update the entire list of what's happened. So that's what we're currently doing right now. And part of this is we need to actually adjust this context builder here, which is to build the exploit task context, because it's using the old structure where we had these tools and output fields, and now we just have the scratch pad right here. Okay, so we can still call the exploit task index, that's fine. And then we get our exploit steps, which is our list. So we bring all that out, and then we get our current step from that. I think I want to modify this though. I think I'm going to take this out, and what we're going to do instead is we're going to do, I think it's exploit task step. There we go. And we'll pass in the state table there. And in fact, I think I even want to take this out right here, where we don't need that. In fact, I want to modify this. I am going to change this to index right here. That way I can keep track of like what we're actually looking at. And I think I can actually take this part out. So when I do that, I'm going to take that out, and we're going to build this real quick. So that is going to be an integer, and we're going to structure this from our get current exploit task. Pass in the state table again. And then we need to we need to import that guy. There we go. So we're going to let this dynamically build each time. Yeah, it's going to add processing overhead, but it's also going to make it a little bit more robust, in my opinion. Yeah, Gumby's quick on the draw there. What is this song? Blazing Pace? Okay, that's another one that's got to go. Where's my... So I recently added a whole bunch of new background music, but it was a huge list, and one of the viewers actually sent it to me from his own GitHub repo. And so it's got a lot of really awesome songs in there. If you do an exclamation point music, you'll see the list in there. But the problem is, a lot of it's not good for background music. So as I'm finding them, I'm basically writing down on a notepad because they're annoying to have on my desk, and then just deleting them out. All right, so after we get this, this is the problem right here, is that it's our output. So we do want to get the task output, or we want to get the step task. So let's do, I'm just going to change this. We're going to make this our scratch pad, which is all the information that we're gathering about this exploit step. We'll change that right there. And we'll change that right there. So that's going to be our scratch pad. So as long as the length is not null, then what we'll do is we'll build that out right there. Yep. So that should be our step task right there. And that should match up to everything we've done in the scratch pad. I think that will work. All right, cool. So let's come back over here. So now we can take this out. Where else is this used in here? That wasn't what I wanted to do. I think it's Shift F6. Nope, that's rename. Let me look at something real quick. Refactor. Where is it in here? Is that really the only usage we've got in here? Oh, okay. Well, that's fine then. All right, so there's our exploit task context. You're the only one that needs it, apparently. All right, here's one of the issues we're going to run into, which is this value right here. This tells it if we're checking for a step failure. So our max step retries is 5. So basically, it should only be able to go through 5 steps. It should only try a step 5 times before it bails out. It's like, okay, this step is no good. Ooh, this is going to suck. Because we don't currently have anything to track how this is being done. Before, what we were doing is we were basically looking at the list and we were checking the length of the list, because what should happen is every tool call should have been like 1 attempt. And so if there were more than 5 tool calls, we'd know that it had failed, or if there were 5 or more. I think what I can do here is we can actually, I think we can avoid this part right here. Because since we're going to be sending the entire chunky list up to the language model, I'm going to comment this part out. Because what we can tell it is, hey, if we're going to mark that current step as failed in here. Okay, so then it's going to come through and check. That's basically this AI message is our logging message. It's not actually being sent to the language model. So that's our exploit step, which is up here. Yeah, and there's our task output. So this right here, oh, we're gonna have to go reformat this too. Ooh. Yeah, that's not gonna work. This will work for the other ones, but it will not work for this. Yep, we're gonna have to make a different version of this. That's formatting our tool output. Actually, I don't think we're even going to need that. Yeah, I think we can actually take this out. I'm going to copy it. I'm going to leave that one in there for now just as like a reference. But we don't actually have to format this. What we can do is we can take the task output here. We could say what we're going to do is we're going to get our step task. So that's this guy right here. In fact, I want to change this because I don't like the way this is being done. Oh, no, actually, I do like that right there. Where's our exploit step in here? Actually, yeah, we can just pull from the exploit step. We can pull that out. So let's go grab that. And what we're going to do is we're just going to pull out the scratch pad here. What is this one here? Life of a junkie. Dude, Bob, you're killing me, bro. Yeah, let's take that one out. There we go. So that should be good there. So then we'll take that there. We'll take our task. We'll take our output. And we should be there. So then we build up our language model call. All right, so now this part's going to have to change right here. Oh, there's so much to change in this. Because before, what we were sending is, we were binding a tool to this. And we basically bound this exploit step status right here. Dang it, we're going to have to... Well, this is actually still part of the main thing, where what we're doing is, rather than sending this guy right here, this exploit step status, which was basically a class that told it how to return all the various pieces of information. Ooh, that's going to have to change. What is this one? Stronger? That's another one that's got to go. There we go. Want some more chill music. Dang, so all of this has to go. Alright, let's do this real quick. So rather than binding the exploit step status, we're going to comment that out, and what we're going to send it now instead is we're going to send this. Oh, this is going to suck. You should play Under the Bleachers by Seymour Butts. I don't know. I'm more partial to Under the Stars by Amanda Hugginkiss. Dang. So what's happening here is... Here, let me show you all this real quick. So we were defining the... With this output formatter, we were defining the shape of what it should be returning with this, which is our status, our revisions, our bools, our everything. So I think we can get away with this if we go make a new output formatter here. Yeah, I think that's what we're going to have to do. So let's go make a new one. So we'll do class, we'll do... I'm going to call it exploit step revisions, and this is going to be based off of a Pydantic model here. You can also do Yellow River by IP Freely. Ooh, that's a good one. You can also do Good Stiff Drink by Haywood Jablomi. Yeah, Haywood Jablomi. That's a good one. Yeah, let's do this. Let's call this our steps. And this is going to be a list of exploit steps. And then we got to define that as a pedantic field in here. Did that one catch you off guard, Gumby? My nephew, so my oldest nephew, for a little bit of context, my oldest brother is actually 15 years older than me. Big family. I'm the youngest of 5. And because of that, my oldest nephew was born when I was 13. And he just got married. Him and his wife are expecting their first child. And he's so cute. Because we were telling jokes around Thanksgiving dinner. And he's like, oh, I don't think you want to hear the jokes my friends say. And then I dropped some pretty raunchy jokes on him. And it was funny because I could tell he never thought of me, Uncle Blaise, as having that sense of humor. I was like, it was really funny to see the look on his face. I was like, oh, your friends are telling inappropriate jokes? You're cute. Listen up, scrub. Let's see. Updated list of... Yeah, we were all young once. That's right. I think that might actually work right there. Exploit step revisions. Yeah, so I think if I do this, or I just do the steps, and I have it pull that out, I think that will work. Hey, thank you. Thank you for coming online. I hope I said that correctly. Welcome in. I hope you're having a wonderful Saturday, man. Yeah, so this is what this model right here is doing is it's defining the shape of the data that the language model should be returning to us.
Bullshit, I can't hear you. Sound off like you got a pair.
Oh, Gumby, you're so full of crap. Oh, no, that was frozen. Why didn't it show up? Ah, this darn thing. So I recently switched my streaming setup to where I have a dedicated streaming computer, and what you're seeing right here on this screen is actually on my desktop. So I can stream that to it, and then that computer is sending out everything to the internet. But it should be showing that information here. Now, come on. So up here, what should be happening is I should have seen that alert like pop up over here. I don't know why it's not though. So I'm still working on some of the bugs in it a little bit. Sorry you were catching strays there, Gumby. Ooh, this is going to be such a pain here. It's okay, I get it. Hey, Mitch, thanks for the follow, brother. Appreciate it, man. I need to finish setting up the alerts also, because currently only the Twitch alerts are actually firing. So there's alerts I need to go set up for Kick and YouTube as well. All right, I think this will work. One thing we'll have to do is we'll actually have to go rework the prompt.
IG, have you tried turning it off and on again?
I do, before every stream, especially since for some reason the SSH tunneling is not working. I don't know why. The tool I'm using is called Royal TS. I do really like it. It works phenomenally well on the Mac side. On the Windows side, it's got some kind of issues. I don't know what caused it. Sometimes the SSH tunnels. So this is a SSH session into the dev box here. So this is just a Chasm VNC. This is an SSH tunnel, and it should be setting up an SSH tunnel to access to do all the port forwarding so that we can access it here in the browser. That's not the browser. Here's the browser. Shut up, baby. I know it. So what we're doing here is we're working on how do we kind of clean this up a bit. But the SSH tunnel, for some reason, just not working. Hey, Crazy. Hey, man, unfortunately, I do have to ask you to just keep it to English in the chat, just because I'm responsible for everything that's said in the chat. And if if you're not speaking English, I can't moderate. I apologize. I've been trying to learn Spanish for a long time. My wife speaks Spanish. I suck at it. I'll be quite frank with you. Hey, Drewski, what's up, man? Welcome in, brother. Happy Saturday. Let's see. He said, I have no idea how I got here, but what are you doing? So Crazy, what we're working on is an AI hacking bot to play hacking capture the flag games. And currently we're doing a massive rewrite of the agent that's in charge of actually exploiting the target, because it was a little bit too structured, and it was messing up the language model when we were trying to do it. It could sometimes it would get it, sometimes it would fail out. It's kind of a bummer, but I think we can actually get better performance at it by making it less structured. So that's what we're doing. Working on Network Plus? Gotcha, man. If you got questions on that, Drewski, just hit me up on Discord, because my earlier life was a Cisco network guy. So networking I've got. So if you need help with that or you got questions on it, just hit me up over on Discord. All right, how am I going to do this now? Ooh, how am I going to do this? So we're getting the scratch pad, but actually what we want to do is we want to tell it everything that's happened. Let me look at the prompt for this real quick. Let me go pull that up. So when we build the language model call, here is our actual prompt that we're using. And we're taking in our task, our output, and our context. Damn, we're going to have to rewrite this entire freaking prompt. That's going to suck. Lame. What do we actually put in the context here? Do we put anything in? Oh, that's actually where we build the context. Okay. So when we build this, what we're going to need to do is we're going to have to add another field to this. And let's call this our exploit steps here. And then what we're going to do is we're actually just going to send the entire thing from the state table. So we'll do Did I get exploit task here? Yeah. So I don't want to send the entire task, but what I want to do is go get all of the steps that we've done so far. Yeah, so there's our exploit task. And then, oh, don't do that. What was that field called? It was just called our steps right there. Yep, so then what we'll do is we'll reference our steps. That's going to be our entire data structure right there. And then we need to actually go over to the prompt and we need to adjust that. We'll kind of see how it works. No, don't do that. Stop it. There's our context. So we got to add some more to this. So what we'll do is we'll put our steps in here. And this is kind of like a faux XML. It just helps the language model think about how it's going to keep track of some of the information you're doing. It's kind of a dumb trick, but it's dumb and it works. Therefore, it's not dumb. So we'll throw in our, oops, I gotta, there we go. So that's got to be done like that. And then we're going to close our faux XML. Oh god, I'm not looking forward to writing this because this was a lot of work to sit here and fix this sucker. Damn it, it's gonna suck. Nice beard, thank you, sir. Muchas gracias. I should learn more Spanish just because I live in Dallas and it'd be very, very good to know. I stopped actually on the side of the road to help this fella. He was stopped in a weird spot on the highway. So I pulled over. I had my wife and my son with me because Honey Badger hadn't been born yet. And I go over and ask him if he needs help. First thing he asked me is, do I speak Spanish? And I knew just enough to tell him no, but my wife does. So then I go get my wife. She comes over to the car, talks to him, and he's like, oh, he's trying to get to this place. I was like, all right, tell him to take these highways and he'll get there. So thankfully my wife was there to help translate. Otherwise I'd had to just break up my phone and we'd Google Translate it. Right now, fiber cables and their specifications are kicking my ass. That's something you're never going to need to know, just to be straight with you, unless you're actually in there terminating fiber, which usually is done once and then never again. It's one of those things that, yeah, you're going to need to learn it for this purposes, but just know that it's something that you're going to want to try and find every little cheat you can to memorize it in the short term. And then once you're done with the exam, promptly brain dump it. Okay, so if it's going to come back with... This is not our exploit step status. Hang on. Where's our output formatter? Exploit step revisions. This is what we're going to put in here. And it's going to complain because we got to import that. All right, there we go. So actually, I think all of this stuff, even with the early RCE, I don't think we actually need this. Oh, I'm going to break so much of this. I know I am. I know it. Ugh. I actually just trimmed up my beard. It's a little bit shorter than it had been because it was looking kind of raggedy. So it's actually a little bit shorter than it had been. I think actually all of this stuff down here too. I love my comments. Bail out because the language model call sucks or failed. All right, let me think about this. So we're going to make our call to the language model. It's going to return all of the exploit steps that are going to come back. And then basically what we're going to do is we're going to return that as a part of this message in here. So let's do that. Let's do... Yeah, so we're going to do... we're going to modify the state table directly. So we'll do state... Let's see, what is it? TAS? Is that it? Or what the field is. TAS, lowercase TAS, that's why. So we're going to set our task, and then what we're going to do is we're going to do state current task, just like that. And then once we get our current task, we're going to go to our, what is that? Output. Because that's where that field is nested under. And then from output, we're going to index that on the current task. I really do want to rename that. And then from there, we want to get our, where is it? So from our exploit task, we have our steps right there. So then we'll do our steps. And our steps should equal the response, let's see. Basically this guy right here. But instead of our arg status, it's going to be whatever it came back from our output formatter, which was, what did we call that? Just steps? Yeah. So rather than step right there. Boom. So I want to put a note in here. So let's see. We'll say update the exploit task steps with the new version from the LLM. Just like that. That's gonna be so freaking ugly. And then now what we need to do is we gotta actually return this data back. So we'll do a return. And what we do is we just return what keys we're gonna update. So we're gonna return our messages key. Let's see. And that's gonna be our, I think our AI messages right here. And then what else we're going to return? We're going to return our task. That's what we're going to return. Trying to remember how to navigate the updates here for the state table. So then we're going to track our new list of tasks, and we're going to basically emit this new copy that we have in the state table. Just like that. Okay. Because we get a local copy of the state table, and then we can do whatever we want to with it, and we just return whatever updates we want to be added to the state table that gets passed on to the next node. So we only want to update these two fields here. So we made changes to the state table, so we're going to update that portion right there. If we wanted to be a little bit more precise about it, we could actually come in right here and just return these particular sections to it. Actually, I take that back. No, we can't, because we need to go return a key that's in this list right here. So we have to return like the entire list of tasks. I think that will work. Oh, now we have to look at the router here. Actually, I think this one will work okay, because it looks at what's our current working exploit task. If it's -1, basically we don't have any working, it sends it back to the agent. If we do have one working, it sends it back to the processor to run through it again. Oh, this is going to be so broken. I know it. Yeah, this needs to go away. Let's see what else we've got in here that's supposedly broken. Expected a task answer. Wait, what is this error saying? Expected type task answer. Got task answer instead. You're killing me, Smalls. There's a way to tell it to ignore that. I want to clean these up because we're doing so much with... There we go. I had to remember what it was. Some of these are really ridiculous, and it gets kind of confused whenever we're working through this. So expected task answer or none, got a task answer. So these are type checking errors where it thinks there's a problem with it, but there's really not. Why are you still checking it? Come on. Update. See, like this right here, it's not matching on this literal. So that one shouldn't be a problem. I'm cleaning these up real quick because I know there's going to be issues down here. Like, I don't know where all of these are coming from. So I don't know, like, why this... So this should actually be ignoring this line. I don't get why it's not. Same thing here, like it's saying the status isn't what it expected. So that one shouldn't matter. Same thing with that one. So this is just a little bit of code cleanup right here. Yeah, don't care about that either. Yeah, I don't care about those either. Okay. Hey, Monkey, what's up, brother? All right. Most of these are kind of cleaned up now. What are these ones down here at the bottom? All of these ones? God, you're annoying. What is it saying here for this? See, that one, it stopped type checking. I don't know why they did. What does it say here? Stinger state is a typed dictionary, you idiot. It's like, I don't like how this is being done. Well, get over it. So all this is a little bit of syntax sugar strictly for the IDE that tells it, no, there's nothing wrong here. You're dumb. Stop trying to help with the type checking. There we go. Now, I wonder if this even actually hot loaded in. Let's see. Well, it actually did. So this is a copy of the LangGraph server. And this is what's actually communicating everything up to this web interface. And as we make changes, it notices the changes and then it hot patches in everything. Maybe the type ignore's got to go on the same line and not above. Maybe. Let's go see. It's worked for all the other ones. I just don't get why this one didn't do it. Check time again? Yeah. Thank you, Gumby. Add one more hour. We'll go a little bit longer just because I don't want to leave this completely halfway. I don't want to leave this like halfway done while I'm in the middle of it because this is so many changes. Yeah. That's weird though. There's a good idea. Easier. That was a good idea, except I don't know why it's not doing it right here. And it's so annoying too. It's like, hey, you're supposed to get a task answer or none. Got a task answer. I'm like, yeah. Yeah. There's your task answer. Idiot. What is this one? More? No. Gotta kill that one too. There we go. Prefer background music with no vocals to it. And see, this one's doing the same thing here. It's like, hey, let me try that too here. If I take that out. It should go above the line that's throwing the error in here. I don't know why it's not. Let me try something real quick. Oh, there we go. Oh, that would have been so much. That would have been so much easier. Why did I just think of that? Okay. So I'm using it's suppressing the wrong inspection right here. Well, that's cool. Yeah, suppress for that statement. And then same thing for this one. We take these out. There we go. Because it makes it crowds up everything so much, it makes it very difficult to see like where there's actual issues instead of all these fake issues in here. These ones up here I don't care about because these are just unused imports I don't care. We'll fix it. We'll clean them up later. That's not a problem. All right, let's see did it hot load. All right, I'm going to try running this again, and 10 will get you 20. It's going to fail hard. Let's see what it does. But we got to run it so we can actually see where it's failing at. It failed so bad on the exploit processor. Right off the rip. Let's see. Let's see. String indices must be integers, not string. All right, where did that one come from? I knew it was going to break anyway, Gumby. I was just hopeful. Oh, so get current exploit step status if the status is working. So actually, this is over in tasking line 74. So let's go pull that one up real quick. Let's see. That should have been working just fine here. Let me see. Where's it throwing this? It says if the step status is working. Let me see. So we go task, index on the list, then we go to output, and then we index on the current exploit task right here. That should come back as our step.
Oh, you're breaking my balls, Gamby. You're breaking my balls.
I love that episode of South Park where Butters is just like, he's trying to act like Hartman, and they're selling, I don't remember what it was, something disgusting. And Butters on the phone like,
Oh no, you're breaking my balls, sir. Sir, you're breaking my balls.
string indices must be integers, not strings? What? So that's our get our current exploit step. Oh, wait, I think I did this wrong. Hang on. So this is our exploit task right here. Oh, yes, this is wrong. So this should have been that's our current exploit task, and then I believe what we need is yeah, that's what we need. So that gives us our task, but then we got to go into steps. Right there. Like that, I believe. Yeah, so that's going to get us into our exploit task object here. And then we have our steps, which is our list of exploit steps. That should work right there. Yeah, let me go try this real quick. So one of the cool things also with this is we can actually come back up to our exploit step planner, and we can rerun it from here. So we can let it go try that. Except that was like way back instead of what it should have done. Should have just reran it after this step. All right, different error, hopefully. Our list is out of range. Line 317? Okay, hold on. Let me do something real quick. I want to suppress for that statement, so that way we don't have these weird checkers. All right, so this is saying the errors on 317 and exploit, which of course is in the revisor. I knew this is the one that was going to give us the most trouble. Wait. Why would that one give us trouble? Index list out of range? Oh, did it not return a tool call? I need to verify the previously generated initial access exploit. What? Okay, so the step planner worked here, but something broke. So if we come into this guy right here, if we look at the input, let's go drill down into the state table, because this is our point of truth for everything. And if we then look at our steps, step task, get a PHP artifact, all right. And then, yeah, all the steps look correct. Why did that one become the working exploit? Hold on. I know why. Yep, I know why. It did that because we changed it from tracking it here to tracking by the function call. And when the function call looks at it, it sees all of them are new and none of them are working, right? So when that happens, it returns a -1. So what happens when you go to a -1 on a list? Python goes to the very end of the list. Yeah. Damn it. Damn it all. Okay, yep, I see what happened here. So it worked, but it didn't work. So here in the step processor, we get the exploit task index, we get our current step. So we can fix this actually. We can, and in fact, I like this idea better here, because eventually I think I want to take this field out, which is the current step right here. So this right here, all it does is it loops over it. I want to do something else here. Let me think about this. So it'll return the index if it finds the first working one. Skip that one. Fight Derby, yeah, already got that one to take out. We can actually just put in another check in here that says, do we have any new that are in here? Yeah, I think that actually would be the easiest one here, because it's going to iterate down the list directly. So what we can say is, if this equals new, And then what we'll do is then we'll return. Actually, we could just combine those. Just like that. So if it equals working or if it equals new. Boom. There we go. That will fix it. So which one was this? Our exploit step planner? Let's try rerunning from here. Now here's where I'm actually expecting it to like really fail out. Yeah. At least it got to the revisor. I do still need the return one because there's multiple states that it could be in, right? Working and new are just the ones that we would operate on, right? So if we had a new step in there, that's what we'd want. But we want to hit either the first new or the first working. There is a possibility that none of them could be new or working, and then we would return the -1. It's a weird case, but I want to keep it in there. I don't think we'd ever actually hit it, Gumby. Okay, so our step processor comes back and says, we're going to call get web shell artifacts. We send all this information in. Okay. We send our output and our context. All right, let's see what it returned back from this. So the task was to get a PHP artifact looking at the output. Tool call was made to get with the arguments output with web shell PHP. The output shows a successful system path, indicates the tool was properly invoked with structured parameters. A path was returned indicating the artifact was successfully created. Artifact is now at a specified location. According to the criteria, the task obtained this artifact. Conclusion, the task was successfully completed. The PHP web shell artifact has been contained and is available. Okay, so then what did it return for our steps? Not exactly what I was expecting. I wanted it to update the entire list in there. Crap. All right, this is where we'll have to pick it up tomorrow night, unfortunately, because it is getting late. And the kids don't give a crap how late Daddy was working. This might be something where we just have to go in and maybe instead of sending the list of the steps, we send the entire exploit task. Yes, I'll go push it.
Incoming transmission from Marano Gumby. Don't forget to push it real good.
Yep, I'm pushing it right now. All right, let's see. Massive overhaul of exploit step processor loop. It's broken. Okay, it should be live up on GitHub now. All right, let's see if there's anybody we can go raid over to on the Twitch side real quick. Let's see if anybody's on InfoSec streams. Nobody's on InfoSec streams. And in fact, even we're in stealth mode. By the way, if you enjoy this kind of stuff, this only tracks currently Twitch and YouTube, but if you see, like, people will be on here, they'll be live, and typically we're the only ones on this late at night, so. Yeah, thanks, Gumby, I appreciate it. All right, so the code's already pushed. So what we're going to pick up with tomorrow is this part right here. I'm thinking rather than sending the list of the steps, what we'll do is we'll actually come in and we'll update the entire exploit task. We'll just do the entire thing. A bit chunkier than I wanted, but we do need to sometimes just give it a mass amount of information to get a mass amount of information back. So let's go see who we can find over on the Twitch side to raid over to. If you have any raid suggestions over on Twitch, feel free to shout them out in chat. Let's see. I love to join this list, but I got nothing to stream. Dude, sometimes even just doing like a co-working stream is cool, man. What I tell folks is just talk to the camera like you're talking to, you're doing like rubber ducky deprogramming. I can't talk. You're doing rubber ducky debugging. So if you don't know what that is, you have a little toy rubber duck, you put it up on your desk, and when you're going through your code or whatever you're learning, you're explaining it to the rubber duck as you're going through and doing it. And so you're saying, okay, yeah, this is why we're doing this, and I don't get it. And basically that just having the conversation with that inanimate object helps out a ton. I do the same thing, but it's to the camera. And I come through and I say, okay, this is what I'm thinking, this is what I'm doing. The benefit I have by talking to the camera is I've got you guys in there telling me when I'm being stupid. It's my own personal Chad GPT. Let's see. Who else do we have that's online right now? We could go check out, guys. Tomorrow night when we come in, we'll start working on the revisor again. Like I said, I think I've got an idea on how to fix this, but we're just going to have to tinker around with it. We're going to have to play with it. Who is this guy? Dr. Foxmeat? What's this guy doing? Hang on one second. Let me adjust something here. I don't know if I can unmute it here. I don't know. He looks really cool. He looks like a wizard. Check this guy out. That's a full-on, like, level 7 wizard. Or no, or like a level 20 wizard. Yeah, we're going to go right over to him. Yeah, let's do that. All right, guys. Unfortunately, that's where I've got to wrap it up. Whoop. Thanks for coming to hang out. We'll keep hacking on HackBot. It will learn. It's going to be able to do this stuff eventually. Do me a favor, when you get over into there, drop a bunch of Hack the Planets. In fact, hang on, let me get a copy of the link here. So that's what we're going to go right over to. Drop some Hack the Planets, say, what's up, Gandalf, and some happy hackers and everything in there. And we'll have a good, show them some love. Everyone, take care. Remember, tomorrow night is Sunday. Tomorrow is Sunday. Might already be your Sunday. Spend some time with your friends and family. Get prepped. Do a tactical retreat to prepare for the full assault on Monday's crushing it mode. What else I got? I think that's it. I got to go check on Sock and see how she's doing. And go check on the kiddos. But everyone, I want y'all to, yeah, love you long time, Gumby. Everyone, y'all have a fantastic rest of your night. I will catch y'all tomorrow. I want y'all to remember one very important thing, which is I love you. Peace.